Hello, ladies and gentlemen. This is a short history of nearly everything by Bill Bryson. This is in the history section of the reading list. So, I came across Bill Bryson's A Short History of Nearly Everything after a lot of drawn out research into history books for this blog that I just had to read, right? So, the reviews are high and the comments, for the most part, were positive. But reviews are helpful, of course, but I think they're really best to approach with a grain of salt. I mean, I've endured many other books that were highly regarded, but they left me with the maddening itch to commit seppuku. But, however, this is not one of those books. So, through the first half, I was surprised by the level of research and intrigued by a lot of the obscure histories and stories of scientists I've never heard of. By the second half, I was blown away by the detail and the depth and the ideas. A short history of nearly everything is exceptional. So I'm impressed not only with Bryson's research into complex topics, but also with his ability to weave together the ideas into an understanding, engaging narrative. This is a must read for anyone interested in science or history. I can't say enough, really. So Bryson divides chapters under main sections, and they include Lost in the Cosmos, which focuses on really the cosmos and some of the physics behind that. The Size of the Earth, which is how do you measure things, large distances. A New Age Dawns is another section, and that really goes into the dawn of modern physics. Dangerous Planet, that's the geology of the Earth, life itself. It goes into the cells and evolution, climate, the road to us. So that covers some of the ice ages and the rise of humans. So nearly 500 pages of content are packed within. And so rather than ramble for days on every topic and ideas, I think I'll just present some of the highlights from the book that reminded me why the world is far more incredible than any of us imagine. So let's just jump right into it. First, in the Lost in the Cosmos section, there's a subsection called How to Build a Universe. And here's a quote from that. Quote, just as there is no place where you can find the edge of the universe, so there is no place where you can stand at the center and say, this is where it all began. This is the centermost point of it all. End quote. We are all at the center of it all. This is the idea of omnicentricity. All roads lead to Rome, and you are Rome, no matter where you stand. Here's another one from Lost in the Cosmos. The subsection is Welcome to the Solar System. Quote, under Drake's equation, you divide the number of stars in a selected portion of the universe by the number of stars that are likely to have planetary systems. Divide that by the number of planetary systems that could theoretically support life. Divide that by the number on which life, having arisen, advances to a state of intelligence, and so on. At each such division, the number shrinks colossally. Yet, even with the most conservative inputs, the number of advanced civilizations just in the Milky Way always works out to be somewhere in the millions. End quote. So, where have all these four-eyed freaks gone? How about star KIC 8462852? Strange light dimming has been seen periodically, confounding astronomers to the cause, as it can't be explained by known phenomena. Is it a Dyson sphere, an alien mega solar structure constructed to capture all solar energy from the host star, perhaps? Probably not, but it certainly makes for a cool story. Okay, what else do we have? Lost in the Cosmos subsection is the Reverend Evans Universe. Quote, imagine a million really weighty cannonballs squeezed down to the size of a marble, and, well, you're still not even close. The core of a neutron star is so dense that a single spoonful of matter from it would weigh 200 billion pounds. End quote. A neutron star has been stripped of all electrons, so the tiny, weighty neutrons pack together to a tight sphere. We don't really have a frame of reference for this. There is nothing on Earth even close to this kind of density. What would happen if we could somehow hold a pin drop of pure neutrons and drop it on the ground? Is this even possible? Would it burrow to the center of the Earth? I don't know. Next, we have a new age dawns, Einstein's universe. Quote, you may not feel outstandingly robust, but if you are an average size adult, you will contain within your modest frame no less than 7 times 10 to the 18 joules of potential energy, enough to explode with the force of 30 very large hydrogen bombs, assuming you knew how to liberate it and really wish to make a point. Even a uranium bomb, the most energetic thing we have produced yet, releases less than 1% of the energy it could release if only we were more cunning. End quote. I don't have anything written down as far as commentary for that quote other than that's insane. So, yes, the idea that we are pure energy, like some of those hippies or gurus or new age psychics talk about, well, it's literally true. We are pure energy. Next, we have a new age dawns, the mighty atom. Quote, every atom you possess has almost certainly passed through several stars and been part of millions of organisms on its way to becoming you. We are each so atomically numerous and so vigorously recycled at death that a significant number of our atoms, up to 1 billion for each of us, it has been suggested, probably once belonged to Shakespeare. 1 billion more each came from Buddha and Genghis Khan and Beethoven and many other historical figures you care to name. End quote. That's pretty amazing, I'd say. However, don't forget that one guy with dysentery from Old English history, what was his name? Alden, I think. Yeah, he lived in East Anglia in 1049 as a lowly peasant, died in his 20s. Last I remember, he got caught wanking it behind the swine stable. Then later the same day, took a hammer to the head from a larger, brutish lad for stealing barley. Yeah, he lived a short, deplorable, disease-ridden life. He's a part of us too. 1 billion or so atoms in each of us. So, there's that. Okay, next. Dangerous planet in the subsection. Bang! Quote, 1 second after entering the atmosphere, the meteorite would slam into the Earth's surface, where the people of Manson had a moment before been going about their business. The meteorite itself would vaporize instantly, but the blast would blow out 1,000 cubic kilometers of rock, earth, and superheated gases. Every living thing within 150 miles that hadn't been killed by the heat of entry would now be killed by the blast. Radiating outward at almost the speed of light would be the initial shock wave, sweeping everything before it. End quote. And then later, quote, for those outside the zone of immediate devastation, the first inkling of catastrophe would be a flash of blinding light, the brightest ever seen by human eyes, followed an instant to a minute or two later by an apocalyptic sight of unimaginable grandeur, a roiling wall of darkness reaching high into the heavens, filling an entire field of view and traveling at thousands of miles per hour. Its approach would be eerily silent, since it would be moving far beyond the speed of sound. Anyone in a tall building in Omaha or Des Moines, say, who chanced to look in the right direction would see a bewildering veil of turmoil, followed by instantaneous oblivion. End quote. With this kind of extraterrestrial impact, it won't matter if you're Buddha, Genghis Khan, or Beethoven, or even our beloved friend Alden. A Yellowstone caldera eruption would look like pop rocks to something of this magnitude. Make no mistake, this kind of impact has happened, and it likely could happen again. There is evidence of such an impact at the end of the Younger Dryas, which coincides roughly with the end of the last ice age. Outspoken researchers like Randall Carlson, Graham Hancock, and Robert Schoch insist the evidence for global cataclysm as recent as 14,000 years ago is now overwhelming. Countless peer-reviewed research papers add support to this theory. As a side note, Schoch believes a mass coronal solar ejections rather than celestial impacts were the primary disaster trigger, but really the side effects or total impacts around the globe were roughly equivalent and equally as devastating, I should add. What about the mythology of tribes and ancient cultures throughout the world? They are consistent with the notion of a cataclysmic event coming from the heavens. Immanuel Velikovsky elaborates on this theory in his book Worlds in Collision, referring to numerous cultures that describe a quote-unquote serpent in the sky that comes to earth to cause death and destruction. I doubt his theory on Venus beginning as a comet has any weight to it, but the idea of ancient cultures viewing a comet as a serpent of death coming to reset the world certainly does. At the very least, we can't throw out the ideas presented forth in the theory of catastrophism. In Chelyabinsk, Russia, 2013, a meteor exploded about 20 miles above the city at the speed of over 40,000 miles per hour. About 1,000 people were injured with no fatalities. But if this meteor was a little larger, a little heavier, a little faster, or even came in at a slightly steeper angle, many people would have died. And maybe we would have started taking these type of things a little more seriously. In 1908, the Tunguska impact in Siberia flattened 770 square miles of forest, killing everything within the radius. If this happened over a populated area, there would have been massive casualties. Earth's orbit takes us through the torrid meteor shower twice per year. This interstellar field of debris is a possible culprit for some of the impacts and close calls our planet has endured. Not to overstate the threat, but we certainly need to take this issue more seriously and I think develop some kind of defensive program. I think the extreme cost to develop an asteroid detection and deflection scheme would pay for itself many, many times over after thwarting an object with global cataclysm potential.